So we have been talking about scale factor for like a week now. And now we're going to bring in scale factor of solids. When did we deal with solids? When did we deal with solids? Look at the pictures that are on that paper. When did we deal with that? The last unit. What were we finding? Volume. Okay, so you don't want to forget everything you've learned, but we're going to deal more with scale factor on these solids. So at the beginning of the unit, we talked about similarity. Last year in IM1, you dealt with congruency, where things were exactly the same, right? For similarity, you have two solids that have equal ratios of corresponding linear measurements. All that means is you are matching up the sides between one figure and the next, and if their ratios are the same, those solids are similar to each other. Okay, so for instance, if I'm looking at these pyramids here, what does 3 match up to in my larger pyramid? 6. They're the same side, right? So 3 over 6, that's a ratio. It's a comparison of those two sides. What does that reduce to? 1/2. Okay. What about 2? What side does that match to in the large one? 4. Okay, and what does 2 over 4 reduce to? 1/2. And then lastly, I have this slanted side length. So 5 matches with 10, and that reduces to 1/2. All of these ratios are exactly the same, which means those figures are similar. Okay, so if the ratios are exactly the same, those figures are similar. Scale factor is the common ratio of the linear measurements. Since all of those ratios are the same, that is also the scale factor for those two figures. For scale factor, we have image over pre-image, right? Based on what the scale factor is, so based on the fact that it's 1/2, do I have a reduction or an enlargement? A reduction. I have a reduction. So which one of these figures is my image, my new figure? The one on the left, the small one. My pre-image is the larger one, because I have a scale factor of 1/2, which means I had a reduction. Okay. Yes?
So how do we know that before we know the image and pre-image?
You're going to be told how to compare them. Typically, it'll say go from left to right or small to big. Okay. In this case, I just chose the image over pre-image. We could have done it the other way. But based on what our scale factor was, this is our image, this is our pre-image. Had we had everything flipped, those would have also been flipped. Okay. So if two solids are similar, meaning their scale factors are the same with corresponding side lengths, they have a ratio of A to B, right? We have our ratio. When we're dealing with volume, our ratio changes a little bit. What are our units for volume? Cubed, right? Something cubed. So we have cubic units, which means if we know what our scale factor is, if we want what's called the ratio of volumes, we are going to cube our scale factor. So what's our scale factor again for the problem above? 1/2. But I want the ratio of volumes, so I'm going to cube my scale factor. What is 1 to the 3rd power? 1. 1 times 1 times 1 is 1. What is 2 to the 3rd power? 8. 2 times 2 times 2 is 8. So this ratio here is called my ratio of volumes. That should have an S on it. My ratio of volumes. So you start with scale factor. So this is my scale factor. You cube it to get your ratio of volumes. Are we okay with that so far? Okay, so if two pyramids have a side ratio of 3 to 2, how else can I write 3 to 2? 3 over 2. Right, that's how we're going to look at scale factor. So those two pyramids have a ratio of 3 to 2. Before we look at anything else, is this a reduction or an enlargement? I've heard both. It's an enlargement. What is 3/2 as a decimal? 1.5, which means my scale factor is greater than 1, so my figure gets bigger. So based on that information, which one of these is my image, my new figure? The big one. Okay, so here's my image. Here's my pre-image. Now, I'm already told that the scale factor is 3 over 2, but I could check it. So image, which is 3, over pre-image, which is 2. Do you see that? Image, which is 6, over pre-image, which would be 4, and 6 over 4 reduces to 3 over 2. And then image, which is 9, over 6 reduces to 3 over 2. So I'm getting the same scale factor. I've just showed you how we got that. Okay? Everyone okay with that so far? Yeah? All right. Find the ratio. We're going to take out surface area. We're not dealing with surface area. So you can cross out surface area. Find the ratio of their volumes. Okay, ratio of volumes. So I know the scale factor is 3 over 2. And I want the ratio of volumes. What did I do above to find the ratio of volumes? Cube it. 3 to the third power? 27. 2 to the third power? 8. So here is my ratio of volumes. Okay, so the math in this unit is not hard. You just have to kind of remember all the rules for things. So let's go back a second and let's determine if these solids are similar. So again, to determine if they're similar, we are comparing all of their side lengths. Now, because it doesn't tell us, let's go from small to large. Okay, we're going to go from small to large. So what should I compare for the cones? What side lengths or pieces should I compare? Sarah? So if I have the radius in the small one, what would I compare it to in the large one? The radius in the large one, right? So 4 over 6. And that reduces to 2/3. So I've compared the radiuses. Now I need to compare the heights of each of them. And the heights are 6 over 9, which reduces to 2 over 3. Because these are exactly the same, these figures are similar, and my scale factor is 2/3. Why don't you try part B? So determine if those two solids are similar to each other. So someone tell me what they compared first. 6 and 8, so the heights. 6 over 8 reduces to 3 over 4. Okay? Someone else, tell me what you compare next. 8 and 10, okay. And what does 8 and 10 reduce to? 4 over 5. Are those the same? So we're going to stop there. There is no point of doing any other side lengths because we already know they're not similar. Okay, you could have done 4/5 and still seen they're not similar just to have it. But once you have two side lengths that don't have the same ratio, stop. Okay, and your answer here would be not similar. And because they're not similar, there is no scale factor. Are you okay with that? Okay, I want you to do the next three. So again, you went small to large. And this was a good question. So when I say small to large, it literally means small over large. Because you're writing it as a ratio. And remember, you can write ratios as like A to B. So A over B. Okay, what did you compare in number 1? 4 to 6. What are 4 and 6? But what is it in the figure? It's the diameter, right? 4 and 6 are the diameter of those circles, and that reduces to 2/3. And then you compared the height, 6 to 9, which reduces to 2/3. So these figures are similar. Make sure you get used to writing similar, because that will be asked of you on the test. And your scale factor is 2/3. Okay. In number 2, if I compare the radius to the radius, I get 1 over 1. And then I'm going to compare the height, which is 5 to 10, and I get 1/2. You should have gotten not similar. Yeah? Awesome. Did number 3 trick you? No? Okay, so what'd you compare? The 4 and 12, so the height giving you 1/3. And then 1 over 3 for the side lengths and 1 over 3 again. So they are similar. And the scale factor is 1/3. Someone in second period asked me if they want me to write, or if they should write, I don't even know what I'm saying, SF or K. It doesn't matter. So if you write SF for scale factor or K, because we talked about how K also means scale factor, either one of those is fine. Remember, they're interchangeable. Okay? Any questions on that part? Do we need to see any more of those? Because there's 2 more, but I think we're okay with deciding if they're similar. Okay, so let's go to example number 5. So what is the ratio of the height of the larger cylinder to the height of the smaller cylinder? So what is the height of the larger cylinder? 21, and the height of the smaller cylinder? 7, and that reduces to? 3 over 1. So my ratio for the height of the large to the height of the small is 3 over 1. What is the ratio of the radius of the larger cylinder to the radius of the smaller one? So larger is 12, smaller is 4. So you still get 3 over 1, which you should, right? Because if they're the same, then we know these two are similar. Find the ratio of volumes. So what do I do again if I want ratio of volumes? Cube it. 3 to the 3rd power, 27. 1 to the 3rd power, 1. So my ratio of volumes is 27 over 1. You're going to need a calculator if you don't have one for the next couple ones, because I'm going to make your life so great. All right, so far so good, right? Hopefully? Yeah? Okay. So, if the volume of 2 similar solids is 2,304 inches cubed and 972 inches cubed, find the scale factor. Okay. Right now, what do I know? What information was I given? The volume. And it says here, go large to small, right? So the volume of the large is 2,304. The volume of the small is 972. Everyone okay with that? Now, when we have a ratio, what is the first thing we should always do? Simplify it. So what number goes into both of those? 2 for sure. Okay, so let's start with 2. 2304 divided by 2 gives you 1,152. And 972 divided by 2 gives you 486. Pretty sure I can reduce that more. Why don't we try 12 here? 1152 divided by 12.
Oh, no, 36.
Oh, hold on. Okay, if I divide this by 12, I get 96. If I divide 486 by 12, oh, that doesn't work.
36.
From here?
Yes. No, from the first one.
Oh, well, we're going from here. I'm gonna, 12 didn't work on that part. What else can I try? 18? Someone said 18. 1152 divided by 18 gives me 64.
Yeah,
That's good. And 486 divided by 18 gives me 27. Can you think of anything else that goes into 64 and 27? No. Okay, so that's all the way reduced. This right here is your ratio of volumes. Okay, we took our volumes and we reduced it, right? So it's a ratio of those volumes. Are you okay with that? But we have to now work backwards because I want scale factor. So let's just kind of think for a second. If I had scale factor and I went to ratio of volumes, I cubed it. But now I have ratio of volumes and I'm going backwards to scale factor. Any guesses on what I might do? Not the square root, but close. We're going to take the cube root. The cube root. Okay, I'm going to show you 2 ways to do this. When we were taking the square root and you had to simplify a square root, what did you do? You did the factor tree and you circled pairs, right? So, right? So if I take the cube root of 64, for instance, and I do the factor tree, what numbers multiply to 64? 8 and 8, right? 4 and 2, 2 and 2, 4 and 2, 2 and 2. So same process. The difference is I'm taking the cube root, so I'm looking for groups of 3 instead of groups of 2. So what do you see as a group of 3? I see 3 2s and another set of 3 2s. And just like when we took the square root, the groups come out of the square root. So 2 times 2 gives me 4. The cube root of 64 is 4. That is in my numerator. I'm going to do the same thing with the denominator. What numbers multiply to 27? 9 times 3, and then 3 and 3. Do I have a group of 3s? Or, sorry. Yes. So those 3s come out, and my scale factor is 4/3. Now you probably don't want to do a factor tree every time, so let me show you how to use your calculator. Yep. So all of these, so that's a good question. Will you just ignore the singles? If there were some left over, they would go back inside of the square root. But these ones are gone since I broke them down. Okay? If you have anything left over, it's not simplified all the way. For this type of problem, you will get a whole number answer. If you don't, you need to go back and figure out what your simplifying is. Okay, so let me show you how to use your calculator so you don't necessarily have to use the factor tree. So if you have the same calculator as me, if you don't, I'll come around and help you. But if you have the same calculator as me, right underneath the pi button, you should see a button that says x square root. Do you see that? Okay, we're taking the cube root. So I'm going to press 3 for cube root, and then second, and that x square root button. Right now that says the cube root of, and then I'm going to type in 64, and when I press enter, it gives me an answer of 4.
Oh, okay.
Okay? Some of you have an actual cube root button on your calculator, and I will help you use that. Yep. So if you have, can I borrow your calculator real quick? If you have this calculator, this Casio, right here, if you press second and then the square root button, it gives you a cube root, and you just type in 64, and it's automatically there for you. Okay, hopefully you have one of those two. Is there someone who has another calculator and not quite sure how to use it? Okay. So while I go help a few people out, what I would like you to do is just confirm that the cube root of 27 by plugging it into your calculator is 3. All right, let's do the last one. So if the volume of the two similar solids is 108 pi, and it says small to large, over 864 pi, we're looking for scale factor. What happens with the pi's? They cancel each other out. So all you have is 108 over 864. Take a second and see if you can reduce 108 and 864. So you all reduced it and you got down to 1/8, right? You divided by 2 or 4 or whatever you divided by. Agreed? Okay. Then to find this, actually before I do that, I'm going to show you another trick on your calculator and you're going to maybe love me. Maybe. So you had to think about what number went into 108 and 864. And you may have done it multiple times, right? What if I told you I could just press a couple buttons and get the answer?
That's cheating. How do you do that?
Okay, so if you want to learn the trick, watch carefully. 108, if you have the TI, see this ABC button? The Casios actually have a fraction button, so you might not even need it. But the TIs, 108, the ABC button, and then 864. Right here.
What is that?
How come I didn't use it on the top one? So let me show you what happens with the top one. The difference between the two fractions. What's the difference that you notice between this fraction here and this fraction here? This one here is improper, right? So if I plug in 1152 ABC 8 or 486, this is what my calculator is going to give me. What is that? It's a mixed number. It's 2 and 10/27. If you know how to convert a mixed number to an improper fraction,
that's easy.
Then you can do this, right?
Right.
2 times 27 plus 10 gives me 64 over 27, which is what I got here. So if you understand how to convert from a mixed number to an improper fraction, you can always use the ABC button. If you don't, then you can only use the ABC button when your numerator is smaller. Okay, because it's going to give you an improper fraction when your numerator is larger. You have a fraction button. I'll show you in a second. Okay, last step is taking the cube root, and hopefully you plug that into your calculator. What is the cube root of 1? 1. And what's the cube root of 8?
64 times 8 is 2, 3.
It's just 2. Because 2 times 2 times 2 gives me 8. Remember, you can plug it into your calculator. So cube root of 8 is 2.